In this video, I'm going to look at how to find the reduced row echelon form of a matrix using Python. I'm going to do this only using SymPy for reasons that I think might become clear at the end of the video. NumPy does not have a built-in way to find the reduced row echelon form or echelon form of a matrix. All right, so I recommend following along in the Colab document or just kind of typing it in on your own. Somewhere you can run Python. So first we'll import the functions that we need to do this. And if we're trying to row reduce the matrix that we can see right here, this matrix A, first we need to define it using this syntax. And to convert to reduced row echelon form, it's a little complicated. It's a.rref and then open close parentheses and then 0 in brackets. And we get this as our answer. So we get this nice output of the reduced row echelon form of A. We can also, if we wanted to, just get echelon form. And notice here, we can see we have the same pivots, right? Reduced row echelon form and any other matrix in echelon form have the same pivot entries, but here we haven't reduced all the way to reduced row echelon form. In reality, that's not something you would usually do using software because there's not a huge downside to going all the way to reduced row echelon form, right? When you're doing it by hand, it makes sense to be worried about how long something takes and not do all these extra steps. But when you've already entered something into a computer, it's not a big deal to just go all the way to reduced row echelon form. All right, so that's the basic command for getting a matrix using SymPy into reduced row echelon form. Let's look at some details of things that can happen that are worth being aware of. All right, so what if we have a matrix that contains fractions in the original matrix? So here I'll go to this matrix B that I've added a single fraction in. I'll define the matrix, and let's see what happens when I try to do the same thing. So notice that the output I get has decimals. Nothing wrong with this. If that's what you want, you could convert the decimals back to fractions. But if you want to be consistent, that is, you're starting with fractions and you want an answer that has fractions, you can fix this in the way you define B. So you can define B using this S command, which is going to interpret everything symbolically so that you don't divide, 1 by 2 and get a decimal. And then when I run the reduced row echelon command, I get fractions. And you can, if you want, verify that this output is correct. That is, it's the same, it matches up with this previous output in terms of converting between decimals and fractions. All right, so another thing can happen, which is almost the opposite issue. So let's say we start with this matrix. It's an integer matrix, and we enter it. And we find the reduced row echelon form, and we get some fractions that maybe we don't want, right? They're it's 17ths, right? And maybe that's not really what you were looking for. You actually did want the decimal output. We can fix that using this .evalf command. So here we get decimal output. This might introduce another problem that you don't actually want, 12 decimal places or whatever they said. And so there's an optional argument in the evalf function that will round to a certain number of significant figures, right? So I put a 3 in there, and that rounded each number to 3 significant figures. All right, so there's one final thing that gets at the reason why NumPy doesn't really have this option. So let's say we're working with a matrix that comes from real world data, and we end up with just a bunch of decimals in there. This would be a common thing to have happen, and we try to use SymPy to convert it to reduced row echelon form. Well, first I'm going to show you what happens when I convert this matrix. So this is the matrix I'm talking about. Here I have the code to enter it. Let's see what happens when I convert this matrix to echelon form. So what you'll notice is that the entry in the third row and the third column is in scientific notation, but is basically 0, right? It's 12 decimal places followed, or 12, sorry, a decimal point followed by 12 zeros followed by 90949. What's going on here is that that number should be 0, but in the computations, there was some rounding error introduced, and it's not 0. Now, what's the problem here? Well, if you convert it to reduced row echelon form, what's going to happen is that you get this pivot in the third row and the third column. But really, if you look at what we typed in echelon form, that shouldn't be a pivot. That should be 0. So this is the reason, at least I think this is the reason, that NumPy doesn't have the built-in ability to convert to echelon form. When you're working with real-world data, you often have this issue where maybe it wouldn't even be useful to convert a matrix to reduced row echelon form, and even if it were useful, potential rounding error issues would significantly change your answer. Often rounding error only causes minor changes to your answer, but you can see here that this minor rounding error, right, this number here is within, like, I don't know, like a trillionth of the correct answer, or I'm kind of, yeah, about a trillionth of the correct answer. And that caused a very wrong answer in reduced row echelon form. And so I think this is why NumPy doesn't allow you to do this, or doesn't have it built in. So how do we fix this? Because I still want to be able to find the reduced row echelon form of this matrix. And to do it, it's a bit complicated, the syntax, but basically what this is going to do is it's going to turn all the decimals into fractions to start, and then it's going to find the reduced row echelon form. So it's doing symbolic calculations, so we won't have this issue. And so notice that when I do this, what I end up getting, oh, sorry, this is, I was going to say there's a typo here. This is D. I got an answer that didn't make any sense. So let's redo that. There we go. I got a matrix of the wrong dimension, which is obviously not right. Okay, so here's what we should have gotten. And when we do this, we see that we get a very different answer. Right? And this matches up more with what we had in echelon form, right? Because in echelon form, what we really saw was that this should have been a 0, which would make this the next pivot, and this a 0, and that's what we get here. So this is important if you're dealing with matrices with decimals in them. You have to start being worried about rounding error. It's not something that we'll always worry about in this course, but it should be in the back of your mind. Okay, so again, that was a bit of a quick overview of what's in this document, just so that gives you some context. But to really understand it, I recommend going through it yourself, running all the code, modifying the code for examples that you're trying to solve, and trying to do that to understand how it works.